Twitch. This week it's YouTube.
Hey everybody, we are finally live. We are live, I think, for the fourth time in 5 minutes.
Sorry, sorry about that.
So let me see.
Yeah.
Let me mute my microphones here. So just wanted to apologize to everybody. We were trying to use a different streaming software so we could broadcast in 4K. But unfortunately, there was a broken connection somewhere way down the line to YouTube. So we are using our tried and true backup, which is StreamYard today. Luckily, Eric came to the rescue and started it up, so we were able to move over quickly. But anyway, welcome to the live stream. We are super excited about today. This show came together relatively quickly, actually, which kind of speaks to the power of the technology we're going to talk about today. We have a very special panel of guests joining us today. You already know Eric, you know Maddie, you know myself and Wendy. But today we also have a brand new to the live stream, Alex. Alex from the Omniverse NVIDIA team. She focuses on generative AI. She'll tell you about her role in a second. We have Mario, who's going to kick off things with a nice show and tell. And then we have Miles Macklin, who most people will hopefully remember from all his great Warp work and the exciting content he's shown on live stream way back when we talked about Warp. So we have a great live stream today. We're not even going to do any other announcements because this is so jam-packed with stuff. So we're going to get right into it. So let's start with Alex. So Alex, can you tell us a little bit about your role and generative AI and how it applies in this situation?
Yeah, of course. So I do product management work for NVIDIA, and my focus has been AI and deep learning. So recently, with all the exciting news with generative AI, and we're constantly thinking about how do we bring that power into the Omniverse platform so that all developers can use that and on Omniverse to bring more powerful tools. So yeah, I would love to hear about your ideas as well. Very excited to be here and share this in 1 hour together. Without further ado, I'm gonna hand over to the stars of the shows today. That's Mario and Miles. Let them introduce themselves.
Thank you, Alex. Hi, everyone. I'm Mario Vivianni. I run developer relations for the Omniverse team. I'm part of the Omniverse Exchange team. So I work with you guys, with the community of developers, and I work on getting all of our developers and partners up to speed on the latest and greatest on Omniverse, and in particular building extensions and connectors to bring all of your greatness into Omniverse. Yeah, I'm very excited to be here to show you some of the stuff that we've been cooking around generative AI. Again, no spoilers. I'll pass over to Miles for his introduction.
Thanks, Mario. My name is Miles Macklin. I've been at NVIDIA around 10, 11 years, and I've worked on everything from real-time physics to robotics and now Omniverse. And part of that is a product that I manage now, which is called Warp. It's a way of writing GPU programs inside of Omniverse in Python really easily. And we're looking at generative AI applied to that. So that's what I'm going to be talking about today.
Awesome. And Eric, people know you probably from your live streams. You're a veteran streamer, but do you want to talk about your role in this project a little bit?
Yeah, I chipped in and I helped Mario develop the extension that Mario had, and I specialized in anything to do with deep search in the extension that we'll be showing off today, and it was so fun. I can't wait to show everyone what we've done.
Yes. Okay. With that being said, let us get the party started. Again, we're going to be showing off a nice show and tell, but this is going to be very, very two-way. So we want you to kind of post your questions in the chat, whether you're watching on YouTube or Twitch. We'd love to help answer that. Time permitting, we might hop on Discord afterwards and answer your questions live if you want to unmute your mic later. But let's get started. So Mario, you have prepared a kind of little workflow here for us.
Indeed, I have. So, guys, let me just first of all, because we want to show you a very cool demo. It's not just a demo because we will share more about this in a second. But before I share the video, I want to give a little bit of introduction and explain what we've been working on. So everyone is working with generative AI now, right? I would say that is the hottest topic everywhere, and for sure is a very hot topic for us as well at NVIDIA. So one thing that we've been exploring over the last few weeks, working with Alex and Eric and the rest of the team, is how we can bring more of the generative AI goodness into Omniverse as well. So it all actually started as an internal experiment that we were running with ChatGPT in particular. We wanted to see how far we could push ChatGPT to generate items and in particular information about items, and how much we could reproduce that information into a 3D scene in Omniverse. So the goal was to have a large language model, again, ChatGPT, being instructed on generating a room, so generating furniture and items for a room, just given a text prompt, and then generate those items into the scene. At first, he felt it was a bit of a daunting exercise. It turned out something that we could put together very quickly. Actually, everything that you will see today, the first version of it, which is like 99% of what we're going to show today, we put together as an extension, actually as 2 extensions, in less than 4 days. And that was thanks to the great help from Eric. Jen, we should also mention, she's probably following us from home, and the rest of the team. Everyone pitched in into building this idea. So I would say that probably, showing it is better than words. So how about we show the video? So let me just see what is the best way to share the video, Edmar, here.
Let me see. So you have a YouTube link, right? The unlisted link.
I have the YouTube link. Yes.
I believe if you present, you should be able to play the video and it should play back. Is that correct, Eric?
Eric, I think you're on mute.
Of course. Or if you have the video file, you upload it to YouTube, you can share a video file.
I can share directly the video file.
Yeah, that'd take a minute to upload, I would think. So I would just, yeah, it should share your audio. Let me see.
Yeah, the video doesn't have audio, so I think it should be fine.
Oh, okay. In that case, yeah.
Just give me 1 second.
Yeah, just side note that we had this all set up for our other software, so that's why we're taking a couple extra moments now to get this working in StreamYard. So thanks for your patience, everybody. Again, feel free to post your questions. I did post a link to the Medium article, which was just published a couple of days ago. That's going to go more in depth on some parts of what we're talking about today. So feel free to check out that article. And yes, the GitHub link for the extension was posted also in the chat for everybody.
Okay. So I think I'll probably try to share the video file itself. Just give me 1 second.
Okay. Yeah, let me share that. I'll pop that link up on the, there we go. Yeah, so someone asked if the extension is available yet, and you can get the source code if you follow that link. So
there you go. I think you guys I should show up now. I think Wendy, I think you're the one that can put it on the live stream.
I think it's Eric, actually.
Yeah, Eric.
Oh, Eric, sorry.
The lead on that one. So the YouTube server just went back up. It was
of course.
So that was what the issue was.
Oh gosh. So are we waiting to show that video, or do I need to do
the video should show
let's
up.
show the video.
I have loaded it up. It should show up for you.
Oh, I see. Oh, present. I'm sorry, private chat. Oh, let me see if I go to present and then video file, it just opens up a screen there.
I just shared it. I don't know if it should show up in the bottom bar for you, where you should be able to push it live on the stream.
Oh, I see. Oh, of course. There we go. Here it goes.
Perfect. Awesome. Thank you, Eric. And I think I can control playback from here. Awesome. All right. So let's start with the demo. So as I said before, what we did is we took this idea of ChatGPT generating items into a 3D scene, and we actually baked it into an extension. We actually been working on it quite a bit. We refined the code, we refactored the code. So the demo that I'm about to show today, I'm actually very pleased to say that is actually already available. It's live on GitHub, and you guys can go and grab it. We'll share the link in a second. So everything that I'm sharing today is already part of the GitHub demo. So let's start. Let's say that we have this, floor plan here, and we want to generate some items into it. Here's our extension on the right. The first thing that we have to do is we need to configure some settings. First of all, we need to add the OpenAI API key, because we're using ChatGPT. In this case, we're using actually GPT-4. I'll talk about that in a second. And then there are two other settings that you need to configure, which are the Omniverse Nucleus path and the path filter. Those are used to look for a specific folder in Nucleus for the right items to be then searched on and generated by deep search. One caveat is that Nucleus, the deep search functionality is currently only available to Omniverse Enterprise customers, but don't worry, we have something even for all the other users of Omniverse. But first of all, we'll show you that. So you configure these few settings here. Again, don't worry, don't try to copy my OpenAI key, because I already invalidated it, of course. So the next thing that we have to do is we need to select where we want to generate our items. Let's say that this is the area where we want to generate the item. One thing that we can do is to take a pencil, and then we literally draw the area where we want to drop our items in. Again, here it's me drawing very badly an area, but you don't need to be precise, because as soon as you click enter, the curve is generated, and we have it here. Then you just need to name it. In this case, we want to create a warehouse, so we put warehouse in here, and then we just click create. And this, as you can see, generates a primitive. It generates a plane there. And now what we can do is we can actually add a prompt to define what items we want to generate in here. It's a warehouse. So we are adding a generic prompt that says generate items that would be commonly found in a small warehouse. So again, we're using just natural language. We haven't added any information about what it needs to be generated. We select the use ChatGPT and use deep search, because we want to use both functionalities. We click generate, and then this start processing. So what is happening under the hood is that it's connecting to ChatGPT. ChatGPT is generating a JSON of information with the right information in, and then deep search searches for the right items in here. As you will see, in a few seconds, it actually searched in our SIM library as a SIM-ready library of assets, and it generated items that you can find in a small warehouse. So you have a forklift, you have a few racks with packs on, and all we have to do was just to, add a few lines of natural language into it. So, and as you can see, there are a lot of items that have been generated, packets, there are some boxes in there, there is again this forklift. So, and we can always, if we don't like the setup, we can always grab these items, and it's still Omniverse, so we can engage and interact with these items in any way that you want. But you already did a very good job of generating and distributing those assets in the right place, and those items are very relevant. Consider that it's scraping thousands and thousands of assets. Now we want to do another example. Now we want to generate a reception room, a much bigger room. And let's say that this is our warehouse. This is a reception where we usually host our guests when they come visit and they need to grab their own parcel. We could say that. So all we have to do is, again, we have our curve that is being created. We call it reception. And then we click create again, and this generates again the floor. And this time we want to add a prompt that it is a little bit more dense. We already prepared a prompt here that says, this is our reception room where we welcome visitors as they came to visit and get their parcels. It contains a few items that you would find in a reception room. So again, here we're very descriptive, we're very natural in our language. We just click generate, and then within a few seconds, this still generates some items. And again, this is actually pretty decently structured reception room, right? We have a few sofas, we have a couple of coffee tables, and we have a few armchairs as well. So it did actually a pretty decent job of creating in just a few seconds, completely automatically, generate a set of items. And if we expand, as you can see, there are sofas, armchair, coffee tables, and more. And the cool thing here is that you can actually expand. The more descriptive you are in your prompt, the more details you provide to the prompt, the better will be the definition of your scene. So it doesn't actually stop here. We added an additional functionality because you might not really like the specific individual item that you have here. So what if I tell you that with the click of a button, you can swap through a variety of other similar items? And that's the great extension that Eric has created, which is called Deep Search Swap. Is still a small companion extension that is still part of our AI room generator. And all you have to do is you have to select one of the items in the scene. You just click add. And then you can, using these left and right arrows, you can just click and swap and get the next item from Deep Search. And again, in this case, we're asking for, this is a elegant armchair. So it's trying to get other leathery, chairs, and it's doing a pretty decent job there. But again, we're fine with this initial one. I think it looked fine. This is just a very quick, very small demo, but I think it demonstrates something incredibly powerful, which is that you can easily combine now these kind of language-driven technologies and then combine them with 3D. As I will show you in a second, everything that this algorithm is doing is just instructing the AI on generating a certain JSON formatted in a certain way. But he's doing and he's instructing the AI in a very natural language and steering it in a very natural way, pretty much how you would instruct a person to fulfill this task, except this task is done automatically by the AI. So this is it for the demo, for this initial demo. We'll do a quick live demo afterwards. But I think it's probably better to show the code, right, Edmar? I think we should be showing how the sausage is made here.
Absolutely. Right? I think we have a lot of people in the chat watching very, very enthusiastically.
Excellent. So let me now stop sharing the video and I will share my screen. All right. Share screen. Here we go. So Eric, I think now you can swap. Perfect. Here we go. Magic. Excellent. So we have, just to show you guys, we have Omniverse open here. We have our, I have here my beautiful content generation extension. And here we have as usual, our wonderful VS Code open. So let me start with explaining a little bit the architecture of AI Room Generator and what we built. Room Generator, again, is an Omniverse extension. So it's still, built in Python. It's, if you're comfortable and already with extension development, you will see that it is built as any other extension, right? So there are a few key components to how the extension behaves and works. So first of all, there is this is what is in front of you is probably the most important component of the extension, which is the system prompts. So the prompts are the actual natural language that is passed to the large language model. So in this case, to the OpenAI system. And there are three components to the prompt. So I don't know if you're familiar with OpenAI API, but the way that it works is that that API takes three parameters. It takes what is called a system input, which is the most important prompt that you can give OpenAI. The system input is literally the main instruction on what the chatbot should do, on what type of text should it generate. So as you can see, our system input says you are an area generator expert. Given an area of a certain size, you can generate a list of items that are appropriate to that area in the right place and with the representative material. And I'll touch on the material in a bit. And then we go in and we explain that we're operating in a 3D space. We're operating in a 3D space. You work in an XYZ coordinate system. We need to explain that X denotes Y, that X denotes width, Y denotes height, Z denotes depth, and then the origin is at 0, 0, 0. We need to give that information because the chatbot, it doesn't really know Omniverse per se, right? It doesn't really know what it should generate. So we need to constrain him into knowing what, like, how do we want to steer it? What environments does it need to understand and what it needs to generate? And so the other thing that we tell him is that he needs to answer by only generating JSON files that contain the following information. And then we give all the information that we need: the area name, the coordinates, the size of the area. That is also very important. We'll see that why in a second. And also a list of all the objects. And then we say for each object, let's say you have a table, you need to give me the object name, the coordinate of the object, the dimension of the objects, and potentially even a material, right? Each object name should include an appropriate adjective. Actually, this is something that we learned as we were building this. It's super interesting. Initially, we were just like, generate a table, generate a desk. But actually, when it comes to then finding the right item, having an adjective really helps because we are using deep search. So deep search, it gives you a better result if you say, find me an elegant leather armchair instead if you versus just asking for a normal armchair, right? So we added all these constraints, and also we tell the AI that objects should be disposed in the area to create the most meaningful layout possible, and the items shouldn't overlap. So again, without spending then too much time on to the rest of the prompt, you can imagine how by just by being more descriptive about the constraint that the AI needs to have, then the AI will perform better. So this is our so-called system input, right? This is our first input. So the way that OpenAI also works is that after the input, the system performs better if you give an example of interaction user-machine. So in this case, they call it assistant because it behaves like an assistant. So we need to provide an example of a user input. In this case, this is how our example input is set up. In this case, we're presenting an example of a warehouse. So you have a warehouse with a certain size, with origin at a certain position, and then we say generate all the appropriate items in the correct places, generate warehouse objects. So the interesting bit is, as you will see when we look at the code, this first part of the prompt, generate a list of appropriate items, yada, yada, yada. This part here is actually what all prompts will contain. We will just dynamically generate this information from the scene itself. So we're pulling, for example, how big is the area, or what is the name of the area, or where is the origin of the area. We're pulling that information from Omniverse, from the primitives in Omniverse. And this is a text that we found. It was helping the prompt. It was generate a list of appropriate items in the correct places. Without that prompt, sometimes it was generating non-deterministic answers. So sometimes it was generating the JSON, but maybe the items were all over the place or in wrong places. And then, so that's our user input. And then there is the final part, which is the assistant input. It's called assistant input. Actually, this is an example of the output that the AI will generate. So as you can see, again, we ask for a 1,000 centimeters by 1,000 centimeter warehouse, and it generated a warehouse area at 000 that is 1,000 by 1,000. And here's an example of all the items that it should generate. Right? And these are just, keep in mind, these are just examples. We wrote these from scratch. Like we invented this JSON. We're basically just telling the AI, here's an example of JSON, generate a similar JSON with similar information based off what the prompt that the user is giving you look like. All right? So this is probably the most important part. It actually took us a few days to do what I think it's a fascinating exercise, which we call prompt engineering, which is like figure out how the prompt works and what is the best prompt. So let's look at the code of the extension itself. Let's start from windows.py. That is literally where we start creating the interface of the extension. So let me show you first what the extension looks like. Again, we have our setting window. We have a set of instructions that helps you understand how to use the extension. And then we have the area name that is taking in any text input, a button that takes the selected object in the scene and converts it into a plane where the objects can be generated into. And this is also taking the width and the length of the plane. That way, we know what information to pass down to the AI. And then we have this drop-down, current room, allows us to then, once we have generated a few rooms, we can easily swap between them and regenerate the content if we don't like what has been created. And then there is the prompt. There are two flags, use ChatGPT and use deep search. We decided to add two flags for two reasons. Number one, deep search, again, is available only to enterprise customers. So if you don't have Omniverse Enterprise right now, if you try to use deep search, it will fail. It will not generate anything because it can't use that feature. Also, we decided to have a flag for use ChatGPT because OpenAI, it's a paid API. So if you want to run some experiments, you might want to run just with the default prompt that we have provided. So if you unflag use ChatGPT, it will just use the default JSON that I just showed you guys. And it will always generate just those items. But you can use that to play with it. Then there is the generate button, and then we have a log that allows us to troubleshoot if something goes wrong. So going back to Visual Studio Code, again, this is a normal extension, right? So we created a scrolling frame because we need to move through it. And here we have all of our labels and buttons, content generation with ChatGPT, our collapsible frames, and etc. But the most important part of the extension is actually the build AI section. We created a specific section for all the AI and deep search functionality. And here we again create the UI, and as you can see, there are when there is this button generate, that is the main button, there is a function called generate that is called, and this function is where we decide what we want to generate, right? So we can click on generate, and then we get into the code. So the first thing that we need to get is the prompt from the UI. And then there are quite a lot of components into what generate does. The main thing that generate does is based on the flags that we have activated. So if he has to use ChatGPT or if he has to use deep search, it will actually do different things. So the main thing that it does is that it creates an asynchronous function, because keep in mind that this is very intensive from a networking perspective. In the video, I kind of cut the elaboration time. It can take a couple minutes actually for both ChatGPT and Deep Search to find the right items and generate them. So we have this method here that is called call generate. And once we get into that, we get into the main part of the code that is the ChatGPT call code. As you can see here, we're doing a few interesting things in the ChatGPT call code. The main thing that we're doing is we need to set up the interaction with OpenAI. So we are taking all the settings that we have, so all the information about like what is the API key, what is the other prompts information, and we are putting it into some parameters. We're creating actually a set of parameters that we will pass to the OpenAI API. In this case, the first thing that we need to pass to OpenAI is the model. Right now, I substituted with GPT-4. By default, the GitHub repository will be set up to be a GPT 3.5 Turbo, which is ChatGPT engine. The reason we're using GPT-4 is because I was lucky enough to be included into the early access for GPT-4, and GPT-4 actually has a much better spatial awareness than ChatGPT. But ChatGPT is pretty good. Don't get me wrong. Just GPT-4 is better, so that's why I'm using it. And then, as you can see, we have a few messages that we're passing the AI. We're passing the system input again. We're passing the user input, the assistant input again. So all these this material that we created before, all these training, if you want, for the AI, all these prompts that helps with the training. And finally, the most important part, we pass the prompt. The prompt, without going into too much detail, is a combination of the information that we're taking from the primitives in Omniverse and the prompt that is written by the user in the text prompt. And then what we're doing is, in this case, we're not using the Python OpenAI library. We're actually creating a HTTP call. That is because we can then build a more asynchronous connection with OpenAI that allows us not to hang the entire user interface of the extension, because otherwise everything runs on a single on the main thread and everything stops until we get a response from OpenAI. So we're doing this using the library AI OHTTP, and we create a new client session, and then we just do a session post, and we're posting all this good stuff here, all this information here. We're passing the JSON parameters to OpenAI. And then we wait for a response. Once we get the response, this is where the magic happens. This text is the information that we're getting back from OpenAI, right? And once we get that, we just need to parse the response that we're getting. And then we are actually good to go. We just need to turn this into a Python object. We need to basically decompile the JSON that we received. We need to split that up and convert it into a normal manageable JSON variable that we can use. And at that point, basically the magic is done, in the sense that we have the JSON with all the information to then populate the actual UI, right? We have all the name of the objects. We have everything, and that's where it actually gets into the actual object generator. And we created a class called item generator, and item generator does two things. There are basically two methods into item generator. One is place deep search results, and I would love Eric, if you want maybe to talk about the deep search part. And then we have the place gray boxes part, because depending if you're selecting or not use deep search, it will either, you want to generate object search in deep search, or you want to just generate gray boxes. So it will generate simple cubes that are then moved and stretched, and materials are applied to it in order to still generate a scene. And that's something that everyone will be able to use because it doesn't require anything special. So Eric, maybe I'll pass over to you if you want to talk a little bit about deep search, because you are our deep search expert here.
Yeah. So for those of you who have not used deep search before, and I hadn't, so it was new to me, deep search will actually go through your assets on a Nucleus server, and it kind of looks at them, and it can learns about them, if you will, or knows about them, and it kind of caches those results. And so what you can do is you can go into a Nucleus server, and you can type in a query for using natural language, and then it will find things. So for example, if you search for a red car, it will actually go through the entire Nucleus server and return any red cars. Well, and it'll return maybe 50 to 100 results. And so the first items will typically be very red car like, and then as it goes, they'll be less and less like a red car. But like Mario pointed out, he had a prompt that was for an elegant chair, and so it's pretty slick that it knows, when you say give me an elegant chair, it knows to look for kind of a contemporary design or some leather or something that's kind of cool, and it really knows. It looks through and will find, using natural language, what you want. So and then of course there are some filters and things you can do. So let's kind of dig into that. And so if you look at the place deep search results, it gives the GPT query, and the query result and the root prim path. And so that's going to help it place. So it's going to basically, you're going to get a list of items with their positions, and then like the root prim where you want to place them into the scene. And let's see here. So right now it's just building that tree structure to place the prims in those first few lines. Where's the search? Let's see here. Here we go. And then, I'm sorry, I'm just a little lost. Create prim. Oh, I see the query. So you've already done the deep search here, haven't you? By the time this gets called.
Yes,
So
we got the query results here.
Yeah.
Yes.
Okay. So when you do that, so that query result, those are the results from deep search. And so, and when you do that, there have been some actions or some questions about that. You can actually filter and say, because you can have images and other files in your Nucleus server. You can say only give me USD files. You can say search.
Maybe Eric, should I open the deepsearch.py and maybe
sure.
should we look at that one?
Yeah, we can talk about that first. So let's look at, query items is the main function this calls, and that just gives it a list of items with that prompt coming back from GPT, and then it will just loops through and searches for each of those and just returns the first result. So if you look at that next call, which is query first, this is where we make a single query, and you can see that first it's filtering down to only USD files, so only 3D assets. And then if you pass in this paths list, what that does is you can give it a list of folder paths within your file, within your Nucleus server that will only search on. This is useful because when you're doing these searches, deep search can't tell the difference between like an individual asset versus an entire scene. And so if you don't filter to folders that are just assets, it might return our entire physics warehouse demo. And so you can pass in these locations where your assets are. And then it's pretty straightforward call. If you go down to line 48, You just call, you put together this query string, and you just call this find function, and it gives you back a list of results. And so I just return those back. And then, so if we go back to that, that placement function.
Just to clarify, the beginning of that query is just some natural language of leather chair or whatever you got.
Yeah. So it'll be like the query. It'll be you'll have your filters. So the EXTS filter will then have like the extensions you want, and then the paths filter will have the search paths that you want, and then there'll be the natural language just query that you want, and then it'll have the Omniverse URL of the Omniverse server where you're searching, and that's what the query is composed of. Great question.
Got it.
And so then once you have those results, we can go back to where we were.
Yeah.
Right here. Here we go. So now what this does is it gives you a list of what GPT gave you back, and then a list of what Deep Search got back, and then a route path where you want to place everything. And this will go item by item. And it'll use, so Deep Search returns a list of path locations to these items. So it's going to create a prim, just an empty one of that place, and then it will add a reference to it that points to that prim that Deep Search found. And then that's that on line 35, that add reference is actually adding that item, adding that reference to it. Now, if you look next, this is a little tricky thing that we did, is we're going to add a custom USD attribute to each of those items. That is the original Deep Search query. And we'll use that later with that other extension, with the Deep Search swap extension. We'll grab that when you click on the plus button in that second extension, it reruns that same query and then it will use that to get your list of results you can kind of swap through. And then it just takes the positions that come back from GPT and puts those into your positions of the object and places it in the scene. It's really not too bad.
Yeah.
People are pretty shocked in the chat.
Yeah, I think the other thing that it was incredible to see Deep Search Deep Search in action is that we have to think about that these items can be hundreds of thousands of items, if not millions of items, and none of them needs to be tagged, right? They could have any file name, right? And that's because the beauty of Deep Search is it uses computer vision to literally identify the 3D object. And so you could name it anything, but it will still identify a table for being a table, a chair for being a chair, a car for being a car, right? And it does, this incredible tagging, AI-driven tagging of those images. And that's what powers this, the fact that just using text search, we can search untagged objects. And those can be your objects you can train on your own assets, on your asset library. It's really remarkable.
And it actually does some sort of caching. So when you add new assets to your Nucleus server, it does a lot of that work in batch behind the scenes, so that when you do run a deep search, it's very fast.
Excellent. Edward, before we move on, is there any question from the community?
Yeah, I think I was just going to note. So first, big thanks to Paul and a couple others who are helping out in the chat. Lots of great questions from people. Thanks to Wendy for pointing out. Someone had mentioned that there was some kind of barrier to people posting questions earlier, unless you were a follower for a month or something. So that was turned off, and I don't know, Twitch must have added that by default. So if you had a problem posting on Twitch earlier, you can try again now, and your question should go through fine. We definitely want to answer people's questions as much as we can. I saw a couple people ask the same question about it. ChatGPT is not generating these assets. What it's doing is basically calling up these assets that Deep Search finds in your own Nucleus. So this is for companies who have these assets already. You can imagine some companies have a ton of assets, and being able to bring them up and catalog them is always a lot of work. So we can.
And I think that is to build on that. I think that is actually why this tool is so powerful, is because all ChatGPT is doing is generating text, right? In this case, is generating a JSON, like this one here, right? The one that we showed before. This is what ChatGPT gives back to you, is a list of information. And the beauty of this is that you can tailor it to be whatever you want. So let's say that instead of getting furniture or objects, we wanted to generate lighting for the scene. You could ask ChatGPT for information about how do I light a scene, generate a list of 100 lights to light up my stage. Or you could create a tool that does exactly this and customize this tool to generate cameras in your scene. You could say, like, generate a set of 50 shots for an internal shooting, and give me all the parameters of the camera. There is actually a small extension that I published a few months ago called Camera Studio. That's exactly what it does, right? You can generate a CSV file through or a JSON file through ChatGPT of configurations of camera, like what is the aperture of the camera, what is the the focal length, and all of that information. If it can be baked into a JSON file, you can then parse that and bring it into Omniverse. So there is literally no limitation to what this can do. And one thing that I think it will be very clear on why this is powerful is because the developers asking those questions are totally right. ChatGPT is not generating the assets. However, we created a second generation function, which is called the place gray boxes function. And this place gray boxes function, what it does is it's not taking deep search items, but it's actually just generating cubes, primitive cubes in the scene. And all it's doing is basically, let me show you the code. Is taking all the parameters as the other one, but is also taking the size of, like, how big the item is, and the material as well. They should be applied. Like, for example, a bookshelf is probably a wooden object, so it will use a wooden material. It creates a primitive. As you can see here, it's creating a cube. And then it's setting the transform attributes, translation, scale, rotation. And then it gets other attributes, extent and size, and it scales it up accordingly. And then finally, it applies a material. It just takes a material. And the cool thing is that if we go back to the prompt that we have, we actually listed the materials in the prompt. It says here, for each object, you need to store material, a reasonable material of the object, using an exact name from the following list. And we gave it, as you can see, a list: plywood, leather pumpkin, leather black, and blah, blah, blah. And look at this. We have a materials.py that contains exactly those materials. And those are Omniverse materials, right? Those are just path to all materials that every Omniverse user has. You can add more. You can just add your materials in here, add the name of the material to the prompt, and voila, you have a cube generator that takes your materials as well. So if the gods of demos are with us today, I will try to do a live demo of this. So cross your fingers and let's see it in action. So I will go back to Omniverse, and here we go. We have our space here. So let's create a new area. Again, let's say they want to create it here. By the way, one thing that you can do is you can create the curve with the pencil, as I showed before. This time I will show you something alternative. You can actually generate a plane. You can just, modify the size of the plane. Let's say, well, something like this. We can expand the plane. And planes work perfectly as well. We can just select this plane here. Let's call this bedroom, okay? Because we want to generate the bedroom this time. I click create, and it creates again the basic plane on top of it. And now I can just add to the prompt and say, let's say this is a modern bedroom. And I think that's actually, that could probably be enough. We could be maybe more specific. Let's say add items that you would find usually there. That should be fair enough. We say use ChatGPT. Look, this time we're not clicking use deep search because we want to generate a gray boxy, and we just click generate, and you start processing it again. This is gonna take probably a few minutes. By the way, GPT-4 much slower than ChatGPT. So if we would do the same exercise with ChatGPT, within a few seconds we would have a result. GPT-4 is slower, at least right now. So it takes a few minutes for it to go and generate items. The other thing that I wanted to say is that even though the deeper and more detailed you are in crafting your prompt helps getting a deterministic result, it's not always a given. We're still working with large language models that are sometimes a little bit unpredictable. Sometimes for example, sometimes what happens is that it does generate the JSON, but maybe it adds a line of text before it that says, here's your JSON. However, for that, it breaks our experience because we're expecting directly the JSON. We don't know how to parse additional text. So sometimes it just crashes, or it just like you need to click generate again to generate some items.
And Mario, all of the query and the response all fit in one query, or did you have to do multiple?
It's all in one query. So basically, right now it doesn't. At least the way that we implemented it, it doesn't retain memory of the previous conversation. It's not really a chatbot. It's always sending the system and the training and your prompt. It doesn't know what happened before. You could totally do that. You could nest it as much as you want. One thing to be taken in account is that ChatGPT and GPT-4, they have a certain amount of text that they can parse, right? So like our prompt is actually already fairly on the longish side. And if you're adding a JSON to that, and possibly a longish JSON, the more you give the AI, the less we'll be able to remember about the previous conversation. So I think that's why like we decided to keep it like with a short memory, with no memory at all, actually, because at least it can always generate something meaningful, basically. So here we go. It worked. And as you can see, it generated actually items for us. And the cool thing is that even though those are cubes, he actually shaped them in meaningful ways. So let's see, created items here. We have a king size bed, pretty nice. We have a nightstand as well. We have a nightstand on the right. So actually he created two nightstands. That's pretty nifty. So probably this is the sense of the bed. That's nice. He created a dresser. That's a very nicely created dresser. And by the way, the cool thing is that, as you can see here, it did apply materials. In this case, the dresser is in wonderful walnut. And then he created a bookshelf and a floor lamp as well. And all of these was just text and cubes being modified accordingly, right? So I think this is pretty powerful. And we could go back here, click generate, and it will cancel the items here and generate a new room. And we could go and be even more descriptive, change the prompt, and be creative there, right? So again, this is a small demo. Again, keep in mind, this is a small experiment. However, we saw when we exposed these to developers last week, there was an onslaught of interest for these. And I'm sure that there will be loads and loads of developers building on top of this. Our goal with exposing this to the community is that others build other AI-driven extensions and tools that leverage this technology. And you don't have to do it like we've done. I think this is one of the ways that you can implement this. But probably there are like a lot of different ways in which you can generate your text, a lot of different ways in you can, parse it and then generate items in here. And I know like we have Miles here as well. I know that we've been stealing a lot of his time in the live stream. Apologies, Miles, but I know he's been doing they've been doing some amazing stuff with other NVIDIA technologies as well. So just sky's the limit.
I'm dying to see
Yeah.
Miles' demo.
I see something happening.
Here we go. Another one. Another one. He created something interesting here. Well, geometric area rug. It's just the wrong. The wrong.
It's on the wall.
This is a floating Aladdin style rug.
It's a tapestry.
It's a tapestry. I love that. Yes, Wendy. It totally is a tapestry. So yeah, so that's it. The GitHub,
Awesome.
the GitHub repo is live. Just go and play with it. You can start generating your gray boxing, GPT-driven gray boxing now, and start creating. We want to see what you guys come up with.
I'm excited about the idea of just switching materials around. I mean, that right there is. I'm so indecisive sometimes when I'm selecting a material for my object. Just love the idea of scrolling through different similar textures. Super cool.
Very cool. Well, as you mentioned earlier, we do have Miles Macklin here. Super exciting to discuss how Warp plays into all this. So, Miles, I think you're going to walk us through and show us some kernel code and some examples.
Yep, let me just share my screen really quick. Can you see that? So
Yes.
can you
Yes.
see that? Yep,
Good.
cool,
Yeah.
great. Yeah, so one thing that Mario's shown a really great application of these large language models to 3D scene generation and content generation. But the other thing I think that we know that they're quite good at is actually assisting with coding tasks and actually helping developers directly write code. And that's kind of what I want to talk about today, is how we've been applying ChatGPT to some of our coding tasks in Omniverse. And the kind of context is around this particular library that we have in Omniverse called Warp that my team looks after. And essentially, just to give a little background, it's a way of writing GPU kernels in Python with a very simple syntax and being able to launch those directly from Python without having to touch CUDA or C++ directly. And so, this generally gives developers really great iteration time, but being Python, it's also, I think, a good fit for some of these language models because they've seen a lot of Python in training. And the way that we actually integrate this into Omniverse is often through something like an OmniGraph node. So this is an example of Warp running an OmniGraph. And this is a simple sort of ocean deformer, creates like a wave effect, like something you might have seen in Moana. And this was created by one of our Warp developers, and he's a VFX veteran who kind of understands how to do all this stuff in code. But the question we wanted to ask is like, how can we use generative AI and ChatGPT to help us write this kind of effect? And so the way that Warp plays into this particular graph is we have this graph this node in the middle that's creating the deformation effect on the mesh. And I think in the video he's going to open it up in a sec and just show you can actually see the code, the Warp kernel code for that node directly inside the UI. So you don't have to jump out to VS Code or some text editor. You can edit this kind of Warp kernel code directly inside the Omniverse UI. And so he's written a bunch of different linear algebra and math functions here to kind of create this procedural effect. The way that we experimented with adding ChatGPT here is by adding, similar to what Mario showed with this prompt box at the top of this kernel node. So this is a little experiment where we have a deformer on the bunny. I want to create like a melting effect. So we have an OmniGraph set up. It's got the bunny on the left coming in and the bunny on the right coming out. And I'm going to show how we can use natural language to actually generate the code for that deformer. So the first thing I'm going to do is just ask it to write a simple compute function to copy the input points to the output. And so I just write the prompt in natural language. Prompt gets sent to ChatGPT, and it's pretty quick. It's given us back a very simple points out equals points in kernel, right? So it's not doing any real work. It's just going to copy the points from one mesh to the other. And you can see when I play the sim, now that we have two copies of the same object. But then we can start, making it more interesting. And I'm going to ask it to say, if you've got a vertex and it's pointing downwards, then move that point down over time. I want to sort of try and make the bunny melt. And if we prompt that, and in a couple of seconds, it's generated some code to look at the normal of each vertex, and it's going to animate that over time, so we get this kind of like drooping effect like this. But you can see it's a bit sort of random, a bit messy, and so I'm going to tune that a little bit more and ask it to scale the offset by a little bit of Perlin noise, which is a really common kind of primitive inside visual effects. So I say scale the offset by some Perlin noise. And it knows how to call into Warp's Perlin noise functions. And you can see it's kind of getting a little more interesting. But one thing I'm noticing with this effect now is that it's kind of like it's melting up sometimes. And so we can tell ChatGPT, be sure to actually make sure that the displacement is just going in the downwards direction following gravity. And I can just prompt it to sort of tune that, and it's going to put a clamp into the kernel to ensure that this is just going in the right direction downwards. So this is the final effect. You can see it creates a pretty nice melting effect as the bunny kind of slowly starts drooping down. Yeah, it's pretty amazing. I mean, so all that, just from some natural language and really quickly converting it into Warp code. So, you can use this to create all sorts of interesting, visual effects, especially for vertex deformation. But Warp kernels can, output more than just points. They can drive textures. They can, compute transforms and all sorts of things. So I think we'll be able to apply it to lots of different parts of Omniverse. I want to talk a little bit about how this actually works now. So just to kind of give a sense of what it looks like on the back end, we're using a similar approach to what Mario described, because ChatGPT in its training never saw Warp code. Warp wasn't released when it was trained, so it couldn't have. And so we use this few-shot learning approach, where we write a small primer on what Warp is and how to use it. And this is just around a 2 or 3 page, like a snippet of documentation, like a sort of a subset of our full docs. It tells it what a Warp kernel is. It tells it some basic math functions that it can call, Perlin noise, things like that. And that's enough for it to then, be able to make calls into our API. We also tell it a little bit about the context in that graph. I said we had the points or the mesh coming in and the mesh going out. So we also add that information into the prompt, and that's all prepended onto what the user types into that prompt box. So it's really, this prompt is very human readable. Like, you could read this documentation yourself and probably learn a little bit about Warp. And, it knows enough, to be able to access things like points, normals, whatever primitive or attributes you have on your meshes. A few sort of interesting observations that I kind of wanted to go over just as we develop this. One is that, it doesn't always get things right. It still makes mistakes about things that Warp doesn't support, that it tries to use. The interesting thing is that often when it makes those mistakes, it's something that is very reasonable to do. Like, I see it making a mistake, I'm like, oh, we should support that. Like, that's something that's actually missing from our API. And so, I think, it's actually it's a way it's starting to guide us in the way that we design our libraries. We should design them such that they're predictable for something like ChatGPT, because in a sense, LLMs represent like your average programmer. It's seen all the good code on the internet, it's seen all the bad code, it's somewhere in the middle. And so if it's trying to do something with your library and it doesn't work, well, maybe your library should actually support that. For the cases where it does get things wrong, we give it some negative prompts, and when we release the code, you'll see like, I tell it to avoid doing certain things, and that actually does work pretty well to kind of guide it around those rough edges. Like Mario mentioned, there is a limit to how much you can put into these prompt headers, and so we can't just paste in our entire documentation into the prompt. But in the future, we're going to be fine-tuning our LLM models on our entire docs and samples and example code, and I think that'll help a lot as well. So yeah, I think that's kind of it. I just wanted to give a really quick overview of it. Warp is on GitHub already. We'll paste the link. We're going to be releasing a new version this week, and there'll be a branch with the LLM code showing the integration of ChatGPT into the Omniverse kernel node. So yeah, happy to take questions.
Thank you so much, Miles. Really, really fantastic. I think it's fair to say that we're barely just scratching the surface here, but we thought it was so important to kind of share this with the community right away, just to get some ideas going. And as Paul and others said in the chat, we honestly we can't wait to see what the community does with this. And like Wendy and I always say in these live streams, it's not an exaggeration that the team is very inspired and motivated by the work that you all do with this technology. So we really can't wait to see what happens. Is there anything we left out? I think we've been keeping on top of most of the questions. Is there anything we left out? Any kind of last words of wisdom you want to let? I think we've mentioned a bunch of links. We've posted them in the chat. For people who can't follow the chat easily, we will add those to the video description afterwards. For any new viewers right now, our videos get saved on NVIDIA Omniverse YouTube channel for viewing whenever it's convenient. They should be available within minutes after the stream ends. Twitch, it'll live for a couple weeks, and then Twitch clears their little hard drive space, I guess. But it lives on YouTube, and then we'll also upload this to NVIDIA On Demand, which is a great resource of other tutorials and videos. I posted our ad event calendar on there. Our next week's stream is also developer focused. Maddie, I hear you have a special guest coming next week. Who is it?
Who is it?
We have Damien. Damien.
I
know that guy.
About Kit.
Troublemaker.
The troublemaker.
The people's choice.
He is. So, and what are you guys going to be covering?
We're going to be talking about new features coming out in Kit, and he's got some behind the scenes things that he's gonna be showing us.
Awesome. So for all the developers that are watching right now, you definitely don't want to miss next week's stream, because Damien is a treasure trove of information. And with Maddie, they're like just a dynamic duo of developer superpowers. So get your questions answered next week as well. But before we say goodbye, does anyone have any last words or comments or something you might have forgotten to mention during the stream today?
No, I'm just really excited. All this ChatGPT stuff, I love it. I can't wait to see what the community does with this.
Yeah, me as well. I think it's going to be a lot of fun. And for those who enjoy watching these streams, definitely subscribe. We actually have 5 weekly streams that happen now. Maddie and Eric are here. They host 2 of them. Ashley hosts a 3rd. And then the Isaac Sim team just debuted their weekly stream yesterday. So every Tuesday at 11 a.m. Pacific, you can catch Isaac talking about Isaac Sim and robotics. So if that interests you, that's every Tuesday. And of course, our official stream is on Wednesdays around this time. Okay, so I don't know. We ran over because we got started a little late. I don't know if the folks on this panel have a few minutes to jump on over to Discord. Okay, there I see some thumbs up. So you guys are in for a special treat. If you want, anyone watching, come over to the Omniverse Discord, discord.gg/NVIDIA Omniverse, We're going to go jump into the community room 1 right now, and you can chat with us live. Ask us questions, something maybe we missed today. You can turn on your webcam if you want, but it would be great to continue the conversation. And this conversation, like I said, is just starting, and it doesn't stop with these live streams. We have a channel called Generative AI on our Discord server as well. So you can hop in there, ask any questions that you missed. I'll work with Alex to make sure we are posting all the great resources for everybody on there. And if you have anything that you really want to see or us to focus on an upcoming live stream, that would be super valuable as well. We do have a live stream channel on Discord that you can post your feedback and suggestions there. I want to thank the great viewers for coming today. Lots of great new faces. Great to see you. We hope to see you on the next live stream. Don't forget to follow and subscribe so you get notifications. Thank you to our great panel today. Really, really fascinating. Amazing that you all put this together so quickly. The community is grateful, and we are grateful for the community. So until next time, thank you, everybody. And we'll see you on
Bye.
Discord.
Thank you, guys.
Thank you all.